I've been adding equipment to my shop that needs three-phase power, and I want to be able to use that equipment, so I've installed a Phase Perfect digital phase converter. I did a lot of the installation of this system myself, even though I have very little electrical experience. But I want to emphasize, I did literally months of reading and watching YouTube videos before I convinced myself that I could do this work safely. Even then, several times during the job, I asked myself, I don't know what to do next, maybe I should just get an electrician. And while doing the job, I was doing it very slowly and cautiously, triple checking everything. And when I was done, I had a licensed electrician come and inspect my work and sign off on it. I'm sharing this video of my experience because I think the information might be helpful, but that doesn't necessarily mean you should or want to do a DIY install yourself. Maybe the information here simply makes it easier for you to coordinate with a professional to do the work. If you do decide to proceed with a DIY install and you have little electrical experience like I have, the only responsible advice I can give is the utmost caution and care and professional guidance. Let's start over here at the main panel. This is actually the main panel for the service to my shop building, which has separate service that was run recently. This panel and the service was installed by an electrical firm in my area. It's 200 amp service, and the breaker I put in is the very first one because nothing here is actually being used yet. One of my favorite features of this new service is that in the meter enclosure, which is on the other side of this wall, there is an exterior disconnect, which means I can throw a switch out there and completely disconnect power to this panel, which means I could do all this work with nothing hot. And each time I come out here to work on something, I double check that disconnect outside to make sure that it's off. And then I used a non-contact voltage check to make sure that there's no power here. Sometimes this device lies to me. If it registers a positive, I believe it, and I check it again with something else, even if I know the breaker is off. If it registers a negative and says there's no power, I don't believe it, and I check it another way. This box here is the Phase Perfect itself. This is the thing that takes single-phase power, which is what comes into my shop, and converts it to three-phase power, which is what some of my machines need. This is a PTE015, which is the enterprise version of the Phase Perfect, and it's rated at about 15 horsepower, which is what the 15 means in the model number. If by chance you work in the software industry like I do, you might find this confusing because in my world, the word enterprise means the best and most expensive. But in Phase Perfect's nomenclature, enterprise is the term they use for the more budget-friendly offering. This is not their top of the line. It's sort of their middle grade Phase Perfect, which turned out to be a pretty good fit for my needs. One of the trickiest parts about buying one of these systems, whether it's a Phase Perfect or a rotary phase converter, is deciding how to size it. I went with 15 horsepower because I convinced myself that there's no combination of machines that I would run at the same time that would exceed 15 horsepower. It's actually kind of likely I could have got by with less, but there's something to be said for sizing with a little extra room. By the same rationale, I tried to talk myself into a 20, but I couldn't quite get there. And then over here, finally, I have a three-phase sub-panel, and this is being fed three-phase power by the Phase Perfect, and this is where I'll put breakers in and run them out to circuits for individual machines. At a high level, the installation is not complicated. We simply need to run one set of wires bringing power in and one set of wires taking power out. The incoming wires connect back here and they go out here through this conduit to my main panel. The output wires, which there are 3 of them because there's 3 phases, come here, go out this conduit over to my sub panel. The manual for the Phase Perfect is pretty decent, although given my level of inexperience, I read it quite a few times. It will spell out the kind and size of wire that you need for each of these cases. For this model, the PTE015, it gave me a choice between 1 AWG, 1 gauge wire, or 1/0 wire. 1/0 is bigger. It's basically an abbreviation for 0 gauge. And the reason why they do that is because then there's 2/0, 3/0, and 4/0, each of which gets successfully bigger. Because in wire gauges, the lower the number, the bigger the wire. I decided to err on the side of caution, and I went with 1/0 wire, which is what this is. And I have 2 of them because I only need 2 wires coming in, plus a ground wire. Phase Perfect recommends that the wires or cable coming in and out be shielded to protect from electromagnetic interference, EMI. I decided to go with this stuff, which is called EMT. In the electrician's world, apparently this stuff is considered great because it's so much lighter than rigid conduit and it's easy to bend. And I cannot imagine why they say that, because this stuff seems heavy and impossible to bend. So the rigid stuff must be just brutal. I decided to not even try and bend it. I bought pre-made elbows. These are 90-degree elbows. And by tweaking everything just right, I was able to use 2 90-degree elbows joined together here with a really short piece. And then they join up with this piece, which was cut off of a 10-foot segment. And the cuts I did with one of those portable bandsaws. I thought this EMT conduit stuff was actually kind of cool, at least until I had to push a 1/0 wire through it. But in general, it worked out fairly well. You buy these tubes and then you need 2 kinds of connectors. You need one kind of connector that goes into a box and it has screw threads on one side. And then you're supposed to get these plastic caps that screw on to cover up those threads inside the box. And then the other kind of connector is when you need to splice 2 pieces together, and that's just a connector with two openings as a splice point. The 2 wires that I needed come out of the conduit over here into the main panel. The ground wire goes down here to this ground bar, which was already there, and the ground bar goes out to the grounding rod installed by the electrical firm earlier. My 2 wires come over here to the breaker. The PTE015 consumes at full load about 90 amps, and they recommend that the breaker feeding it be 125 amps. I think a professional probably would have had an easier task dealing with this really heavy 1/0 wire. It's very hard to deal with and bend and so forth. And originally, my idealistic view was that I was just going to run this right here and I was going to put the breaker here and it would be a nice short trip. And getting everything to do what I wanted was just harder than I thought it would be. And so I ended up running it all around here and sticking the breaker in the middle because that's what worked. Also, at various times during this process, my decisions were affected by reminding myself that I can make the wire shorter, but I cannot make it longer. So anytime I faced a choice between should I cut this wire and then do this, or should I leave it long and see how it goes, I left it long because I knew I didn't want to have to rerun the wire. The 2 wires connect here to this green block back here, and then they have to be tightened down. And there are torque specifications. I didn't know this before I started. When you tighten wires into a block like that, they specify how far you need to torque the nut or screw or bolt or whatever is back there to make sure that you have a really solid connection. Apparently, it is considered legitimate, according to electrical code, to use EMT as a grounding source instead of running a separate wire. I decided not to do that, in part because my whole approach here is to make sure I had the belt and the suspenders, but also because I ended up running this conduit and this wire into the left side of the Phase Perfect box where I drilled a new hole. And the reason why is because the hole that they designed for this is back here. It's hard to see on camera. And that hole was not big enough for the 1.5-inch conduit that I needed to use. I think I could have gotten away with a little bit smaller conduit, but even then it wouldn't have fit without enlarging that hole. I had concerns about enlarging that hole, and I thought, you know, it might be just easier and fewer bends to just drill a hole over here. However, that meant I would be connecting the conduit to a section of the case which is not bare metal. This is powder coated, and I worried about the quality of the connection, the electrical connection between the conduit and this. So I thought, you know, just to be safe, that's another reason to run a separate ground wire. So this ground wire comes through the conduit and connects to the ground block of the Phase Perfect back there. So the single phase power comes in with its 2 wires, and then the Phase Perfect device does its magic, and instead 3 wires come out. And the way I understand this thing works is that L1 and L2 are the 2 wires coming in, and then the wires going out are called T1, T2, and T3. And T1 and T2, the black and red ones, are really just pass-throughs of L1 and L2. All of this thing really does, and I don't mean to diminish its accomplishments, is synthesize or construct this 3rd leg. From here, these 3 wires go out through this flexible conduit over to my subpanel. Which reminds me, why did I use flexible conduit here and EMT, which I think of as rigid but is not rigid, it's EMT. Why did I use 2 different kinds of conduits here? Glad you asked. The reason why is because serious electrical stuff is hard to buy for normal people. I used the stuff I could find retail because I was too intimidated to go into an electrical supply store as a do-it-yourselfer, not a licensed electrician, and ask for stuff. Turns out I could buy 1-inch flex metal conduit and 1.5-inch EMT at big box stores. So that's what I used. If I could have got 1.5-inch flex conduit at a big box store, I probably would have done flex over here as well, but I couldn't find it. You know what else is hard to buy if you're a normal person? Heavy gauge wire. This 1/0 wire, you can't buy that at a big box store. Over here, the outgoing wire from the Phase Perfect to the sub panel, 4-gauge wire. Also, you can't buy that at a big box store. I ended up having to order both of these wires from someplace on the internet. I honestly don't know. If I had walked into one of those intimidating electrical supply stores here in town and asked for 1/0 wire and 4/0 wire, THHN, would they have given it to me? Do they even stock it? I don't know yet. I'll probably find out at some point. You don't have splice connectors with flex conduit, or at least I didn't find any. It seems like what you do is you buy lengths that are long enough and you cut it. And I suspect that if you need to splice 2 lengths together, what you're supposed to do is use a junction box, but I didn't have that problem. I only needed a few feet here. And then you've got these connectors that go into a box, and they have a similar design. Threads on one side, plastic cap to cover the threads, and then to tighten in that flex conduit, you insert it there, and then you tighten what basically looks like a hose clamp to me. Okay, now let's talk a little bit about this sub panel. You know what else you can't buy at big box stores? 3-phase anything. This sub panel, the breakers I plan to put in it, all this stuff, all of it I had to special order from someplace on the internet. This is a QO square D 3-phase panel. It's a main breaker panel. And one of the things that I found odd, but the electrician that came in and inspected this stuff explained it to me. So apparently there's 2 kinds of panels. There's main breaker panels, and then there's panels with no main breaker, it's just lugs. And these are the lugs up here. This one is configured to be used with a main breaker. And so it doesn't come with lugs. It came with a main breaker. But I thought the main breaker would be up here, kind of centered. And instead, it's just sitting down here in the rows where regular breakers would go. And I found that odd, but the electrician said that's just how it is sometimes. He also said, to my relief, that the box electrically doesn't really care where this main breaker is. And that's good because I cut these wires too short. Only after this was all done did I realize that I ran these wires across a section where a regular breaker wants to be, and they're not long enough to make an L and run them up here. However, he said it'll be totally fine to take this breaker, move it down where I get more slack in the wire and can thus run it at more of a 90-degree angle, and the box won't care. In terms of output, the PTE015 will put out 52 amps. So I found myself a little unsure how to size the sub panel. I wanted to make sure that I had enough spaces in the panel because, well, I'd kind of like to do this only once. So I went with this 100 amp panel, but I need to remind myself whether this thing can handle 100 amps or not. I've only got 52 to work with. My understanding is that I could downrate the panel by replacing this 100 amp breaker with something smaller, maybe a 60. I'm not really sure how that would work in practice. I just know that if this breaker is there to protect the Phase Perfect from too much current, it's probably not being very helpful because it's not going to throw till, the ballpark of 100 amps. And this thing can only do 52. So I have an open question here about what that breaker should be. I don't know if this is weird or not. I know that everything about this seemed weird to me, so that's where we are. But this box did not come with a ground bar. There are places where one could be installed, but it's like this accessory that you need to buy after the fact. And so I bought this little tiny ground bar here to have some place to hook up this wire. I'm going to need another ground bar so that I can tie ground wires from circuits coming into breakers so that those machines can be grounded. There's this whole thing online that you read everywhere about how subpanels should not have neutral and ground bonded together. At a main panel, you do bond neutral and ground together, but at a subpanel, you're not supposed to do that. And so I wasn't sure what I was supposed to do here. My understanding is that these bars here are supposed to be neutral bars, or so I understood. And the box comes with this green screw called the box bonding screw with some instructions that basically say, use this if you're supposed to, don't use it if you're not. And if you're supposed to use it to bond neutral and ground together, it goes in here, and then these become neutral and ground together. But this is a subpanel, so I didn't think I was supposed to do that. So I didn't install the little green screw. However, I still was pretty sure, and someone has confirmed for me, that one way or another, this box has to be grounded. And that's why I put in this ground bar. Now, all of that time I spent debating myself takes place in a context which is, where is neutral anyway? The little green screw over in the subpanel is what forced me to understand that the Phase Perfect does not provide neutral. I believe the proper terminology is that Phase Perfect's notion of three-phase is called delta. There are two kinds of three-phase power. There's delta three-phase power and there's Y three-phase power. And when I say Y, it's spelled W-Y-E. Delta three-phase power doesn't have a neutral. Each of the three phases is 120 degrees from the others, and the concept of neutral simply doesn't exist. Y three-phase power isn't 3 wires, it's 4, because it has those 3 phases and it has a neutral wire as well. The Phase Perfect doesn't have a 4th wire, it has 3. And if you read enough Phase Perfect documentation and manuals, you do find this all explained, but if you're like me, don't expect it to make sense on the first read. So, the wires from my Phase Perfect come in here. There are 3 of them. They connect up here to the breaker, but there's nothing connected to neutral. All this stuff up here that's designed for neutral is not connected to anything. So, I guess what I could have done, and I almost did this, was simply redefine all this stuff and say, this isn't neutral anymore, this is now my ground bar. I'm going to install the green screw, which basically means all this is tied to the box, and I'm going to use this for ground. I decided not to do that because I was worried it might look wrong. I'm pretty sure electrically it would not be wrong, but it would look incorrect. That's why I didn't do it. I left all this unused and I put in the little ground bar. And then when the licensed electrician came and inspected all this, he looked it over and he said, you know what, you could have just tied ground to this. So yeah, when I'm working in my own field, I've got enough expertise to know when to break the rules a little bit. Over here, when I'm doing do-it-yourself electrical work and I'm less confident, I'm thinking I'll just stick with the letter of the law. I also learned that when you have holes in electrical boxes that you're not going to use, you're supposed to cap them. And so there's these caps, and they come in standard sizes for standard size holes. For this one in the bottom of the Phase Perfect, that hole I didn't use because it was the wrong size and I didn't want to enlarge it. I got a cap for that one. And then over here on the sub panel, I had a few ups and downs trying to figure out how to put my conduit through. And I ended up making a hole I didn't use, so I put a cap on that one as well. As a basic test, I did throw in one breaker, ran some 10-3 wire and connected it to a 3-phase machine so that I could make sure the whole thing does work, and it does. But then I took that stuff back out because it was just a temporary testing setup. For actual use, I'm going to run, of course, proper circuits and breakers to the machines. As I said earlier, the big box stores that cater to the likes of me do not sell 3-phase stuff. So I had to order my first set of 3-phase breakers, again, from someplace on the internet. One thing they do sell at big box stores is 10-3 Romex. That's what this wire is. 3 10-gauge conductors, one for each phase, plus a ground wire for grounding the machine. My understanding is that this is the right wire to use for these first two breakers, which are 20 and 30 amps. This third breaker for a much bigger machine is a 50 amp breaker, and my 10 gauge wire is not going to be appropriate for that. And big box stores don't sell the heavier wire that I need. I'm going to go ahead and power it up just so that you can see the startup sequence on the screen for the Phase Perfect. And then back over here, you can see this thing waking up. Software version 2049. So one of the reasons that I wanted to show this thing powering on is to just also report these things are noisy, and I'm not talking about a pleasant white noise like a fan that you get used to easily. This is kind of an irritating noise, to be honest. I understand these things are very highly regarded, and I have no regrets about my purchase, and I look forward to using it. But this noise is not this machine's most endearing quality. To be fair, when you put the cover on, it's somewhat less annoying. When you get a little distance away from the box over where my machines are, it's significantly less annoying. But still, I'm not saying this is a pleasant sound. And that reminds me, one of the things I did not do is put in a disconnect switch between my Phase Perfect and the main panel. There's kind of two ways you can manage this. Some people, which is what I've done so far, is that they connect directly to the breaker, and if you want to turn off the Phase Perfect completely, the way you do that is you just throw the breaker. The other way of doing it is you put in a disconnect switch in between so that you can turn it off without touching the breaker. I guess the rationale for that is twofold. One, if you can use a switch that is separate from the main panel, you're further from the main panel. The main panel is less involved. The switch is safer. So it's a safety issue. The second thing is that breakers look like switches, but they're really just masquerading as a switch. They're not designed to be turned on and off lots of times, whereas a disconnect switch is an actual switch. It's designed to be turned on and off. I'm not ruling out the possibility that I may in the future redo this segment to put a disconnect in between. And if I do, one of the reasons why will probably be a desire to turn off that buzzing sound from time to time. But honestly, that decision is going to come down to pretty simple math, which is, which do I hate more? The buzzing sound or wrestling with one-aught wire and conduit? Right now, I could see myself getting used to that buzzing sound. Let's be clear, a Phase Perfect is not inexpensive. A rotary phase converter, which is basically using a three-phase motor to generate that third leg for three-phase power, that approach would have been less costly. But I've seen so many glowing reviews from actual Phase Perfect users, I talked myself into spending a little bit more for what seemed like a premium solution.